It's a tiny moment of frustration we've all experienced. You're pouring syrup on pancakes or ketchup from a brand new bottle. You tip it over and nothing happens. You shake it. You hit the bottom. Then, suddenly, a huge glob splatters out, ruining your perfect breakfast. Or you're at a fancy bar, watching a bartender try to create a beautiful layered cocktail, only to have the colors muddled together. What if every pour was perfect? What if bottles knew exactly how to let their contents flow, and machines could create impossible, gravity-defying designs with liquids? Welcome to Boson Buzz. I'm Monty Molecule, and today we're getting into the fluid dynamics of flawless flow. We're meeting the masters of drip-free design and edible architecture, the engineers of the perfect pour. Our story starts in two places at once. First, in a busy family kitchen on Sunday morning, with a sticky bottle of honey refusing to cooperate. Second, in a high-end chocolate factory, where artisans are trying to pipe intricate designs, but the melted chocolate won't start or stop cleanly. The problem is the same. Liquids are messy. They stick to surfaces, they drip, they don't always start or stop when we want them to. The old solutions are all about fighting the liquid's natural behavior. We add those annoying foil seals you have to peel off. We design bottles with weird shapes to try and guide the flow. But engineers asked a brilliant question. What if we could change the surface the liquid touches, instead of fighting the liquid itself? This brings us to the first miracle of the perfect pour, the non-stick bottle. The secret isn't in the shape of the bottle, but in its invisible skin. Using a technology inspired by nature, like the super slippery surface of a pitcher plant, scientists can treat the inside of a bottle with a microscopic repellent coating. Think of it as a permanent, invisible Teflon coat for liquids. This coating makes the surface so slippery that thick, sticky substances like ketchup, honey, or mayonnaise can't grip onto it. To the sauce, it feels like sliding down a water slide. So when you tip the bottle, gravity pulls the entire mass of sauce smoothly toward the opening. It doesn't cling to the sides. It all moves as one. And when you stop pouring because there's nothing for it to stick to, it snaps back cleanly. No dangling strand, no drip, no need to wipe the lip. Every last bit comes out and the bottle is clean. It's a simple coating that banishes mess from the pantry. But let's take precision to the next level. Imagine you need to deposit a single perfect droplet of medicine onto a microchip, or place a microscopic bead of glue with robot-like accuracy. This is where the perfect pour engineers use something extraordinary: sound waves. They've built printers that don't use nozzles that can clog. Instead, they use focused pulses of sound, like tiny, precise sonic hammers. Here's how it works. A reservoir holds the liquid, say living bio ink for 3D printing tissues. Below it is a sound wave generator. When a specific sound pulse is fired upward, it creates a tiny, controlled pressure wave inside the liquid. This wave pushes against the surface of the liquid, forcing a single, perfect droplet to pinch off and fly upward onto a waiting surface, all without anything ever touching the liquid. It's a contactless pour. This allows for incredible precision with fragile materials, from stem cells to volatile chemicals. Now for the truly mesmerizing part, the art of the pour. In gourmet kitchens and advanced manufacturing, there's a need to build delicate, complex structures out of liquids that then solidify. Think of the lattice on a fancy dessert, or the internal scaffolding for a lab-grown organ. This is where the engineers become artists, using a technique that seems to defy physics. They print in midair. A robotic arm is equipped with a special nozzle that extrudes a liquid gel. But this gel is special. It solidifies the instant it hits light, or a bath of special minerals. The robot moves the nozzle through the air, drawing lines and shapes. As the gel leaves the nozzle, a focused beam of UV light instantly hardens it, freezing the line in place before gravity can make it sag or drip. The nozzle keeps moving, drawing line after line, building a complex, wispy, beautiful structure out of what looks like thin air. It's like a 3D printer that uses light as its paper. Let's watch the perfect pour in action. In a lab, a technician turns a treated honey bottle upside down. The honey flows out in a smooth, glossy ribbon, stops instantly, and leaves the spotless bottle on the counter. In a clean room for electronics, a sound wave printer clicks rhythmically, placing perfect, identical dots of conductive ink onto a flexible screen, each one smaller than a grain of sand. And in a futuristic food lab, a robotic chef is at work. It's creating a delicate sugar cage for a dessert. A stream of molten sugar is extruded. As it arches through the air, a precise laser follows its path, instantly cooling and hardening the sugar strand. The robot weaves an edible chandelier of sugar threads, something no human hand could ever pour so perfectly. The impact of this control is huge. In our daily lives, it means the end of messy condiment bottles and toothpaste tubes. It means less product wasted because it's stuck to the container. In manufacturing, it allows for the creation of new materials with impossible shapes. Ultra-lightweight, strong lattices for aerospace or custom medical implants. The future poured by these engineers is one of zero waste and infinite creativity. Imagine a world where nothing sticky is ever wasted in its package, where artists and chefs can draw with liquids in 3 dimensions, creating edible sculptures and new forms of art, where factories can build at the microscale with perfect, gentle precision. It shows us that by understanding and cooperating with the fundamental physics of fluids, of surface tension, adhesion, and solidification, we can solve everyday annoyances and enable tomorrow's miracles. The perfect pour is about mastery over the mundane to unlock the magnificent. So, the next time you struggle with a stubborn bottle or admire a delicate dessert, think about the invisible science that could make one effortless and the other even more astonishing. If you appreciate when science smooths out life's little wrinkles, please like and subscribe to Boson Buzz. Until next time, have a safe and curious week.